let's say we have the numbers like 12 and 16 again, right? So if I write LCM 12, 16, so the least common multiple of 12 and 16 would just mean like the smallest positive integer that is a multiple of both 12 and 16. And in this case, it would be 48 because 48 is like a multiple of both 12 and 16. So basically the least common multiple of two numbers would just be like the smallest positive integer that is a multiple of like all of your current integers, right? So like if you have LCM AB, this just if this equals like x or something, this just means x is the smallest positive integer so that it's a multiple of both a and b. So that's what the notation means, LCM. So just like greatest common divisor, let's derive a formula for least common multiple. So let's just take the case of two numbers for now. Let's say we had least common multiple of x and y. So to find a general formula for this, again, we're going to use the prime factorizations of x and y just to make our like lives easier, right? So we can say x is like, again, I'll just write it as its prime factorization again as like 2 to the a1, 3 to the a2, 5 to the a3, 7 to the a4, so on. I'll say y is going to equal 2 to the b1, 3 to the b2, 5 to the b3, 7 to the b4, and so on. So the least common multiple is actually like very similar to how you would derive the formula for greatest common divisor. Again, what we're going to do is we're going to look at each term like according to powers of primes. So again, we're going to first focus on these two, like 2 to the a1 and 2 to the b1. So if we have 2 to the a1 and 2 to the b1, clearly the smallest power of 2 that will be a multiple of both 2 to the a1 and 2 to the b1 is going to be 2 to the maximum of a1 and b1. So max just means maximum. So notice that like for greatest common divisor, we did the minimum. Here we're just taking the maximum. And that should make sense, right? Because if we have the numbers like 2 to the third power and 2 to the fifth power, the least common multiple of these two numbers, like the smallest power of 2 that is going to be a multiple of both of these numbers is going to be 2 to the 5, like because 5 is larger than 3. So you would take 2 to the 5, which is the maximum of the exponents, which is why you take 2 to the power of the maximum of a1, b1. And similarly, we can do the similar process for like the powers of 3. So like if you have 3 to the a2, 3 to the b2, then you would just take times 3 to the maximum of a2 and b2. And similarly, you would do the same thing with the 5s. So you'd multiply by 5 to the maximum of a3, b3. And you would continue this process on and on for each of the powers of primes. And this would equal the least common multiple of x and y. So this is, again, just to make the expression easier to understand. Let's suppose we had these two numbers, x and y. Basically, the general process, again, is you first write x and y into its prime factorizations, which are these two equations here. Then you look at each like power of prime. So you first look at the a1 and the b1, you take the maximum of them, which is what you get here. Then you move on to the powers of 3, you take the maximum of a2 and b2, which you get this. Then you move on to the 5s, you take the maximum of a3 and b3, so then you get this. And you repeat that process for all of the primes. So just as an example, let's say we wanted to find like the least common multiple of let's say what's a good number? Like 24 and 36 maybe. So the idea would be you first, again, write them all in terms of their prime factorizations. So you would say 24, you can split this down into 2 and 12. Then you can split 12 into 2 and 6. And then you can split 6 into 2 and 3. So you take these bottom numbers here. So 24 would be 2 cubed times 3 to the 1. Then 36, again, you can decompose 36 as 2 and 18. Then 18 into 2 and 9. Then 9 into 3 and 3. So the prime factorization of 36 is 2 squared times 3 squared. So to find the least common multiple, we would just look at the numbers like by powers of primes. So we first look at this 2 cubed and this 2 squared, clearly 2 cubed is the larger of the two, right? So I'll write LCM 2436. So I'll take the 2 cubed. Then I look at the 3 to the 1 and the 3 squared. Clearly the 3 squared is like bigger than the 3 to the 1. So I'm going to take the 3 squared one. And then we're done. So we would take 2 cubed times 3 squared. That's 8 times 9, which is 72, which is the least common multiple of 24 and 36.